We'll have a look here at how to solve simultaneous equations through the elimination methods. So the elimination method is generally one that you'll use when you have the x's and y's on one side of the equation and then numbers on the other side of the equation. Otherwise we could use the other method, which is a substitution method. So here we're going to use the elimination method. The way it works is you eliminate either the x's or the y's, and you can make the choice as to which one you want to eliminate. So to eliminate the x's, I'll need to have the same number of x's. At the moment I've got 3x and 2x, so different amounts. So what I'll do is I'll take the one equation, I could take this equation at the top, I'll call this equation 1, and I could multiply it by 2. That would give me 6x's. And I could take the bottom equation and multiply it by 3. That would also give me 6x's, and then I'll be able to eliminate. Alternatively, what we could do is times the top equation by 3, which would give me minus 12y, and the bottom equation by 4, which would give me plus 12y, and again that will then allow me to do an elimination method. So up to you which one you go for. This is slightly lower numbers, so maybe the arithmetic is a bit easier, so we'll go for those ones. We'll take equation 1, and we're going to multiply it by 2. That then gives me 3x times 2 is 6x, minus 4y times 2 is minus 8y, and then minus 15 times 2 is minus 30. I'm going to call that the modified equation 2, so a little dash there to show that it's been modified in some way. Then I'm going to take equation 2, and I'm going to multiply that one by 3. So 2x times 3 is 6x, 3y times 3 is 9y, 7 times 3 is 21. So that's my new equation 2. I then have to look at what I would need to do to the two equations in order to cause the elimination to happen. Sometimes I might be adding the two equations together, but in this case I need to subtract them, because if I do 6x and then take away 6x, I'll have no x's. So I should have a plus in between. So I'll take equation 1, and I'm going to subtract equation 2. So 6x take away 6x is nothing. Minus 8y take away positive 9y means that I'm doing minus 8y taking away 9y, so that's going to be minus 17y, and then I'm doing minus 30 take away 21, which is minus 51. We didn't have to do it in that order. We may, if we'd spotted that we had a greater amount of y's on the second equation, we could have done equation 2 and taken away equation 1, and then that would have led us to having positive numbers, which might be easier. What we now need to do is divide both sides by minus 17. So minus 51 divided by minus 17 is going to be positive 3. We then take that answer and substitute it into one of the two top equations. Let's go for the top one. So we're going to substitute our answer that we found now into equation 1. That gives me 3x minus 4 times by 3, because y I now know is equal to 3, and that's equal to negative 15. So 3x take away 12 is equal to minus 15, add 12 to both sides, gives me that 3x is equal to negative 3. Divide both sides by 3, x is equal to negative 1. Always a good idea to then do a check with those numbers in the equation that you didn't use for the substitution. So in this case I haven't used equation 2 yet, so I'll check in that one. If I put minus 1 into here, I'll get 2 times minus 1, that's minus 2. And then 3 times 3 is 9. So minus 2 add 9 is equal to 7, and that's what I was expecting the equation to equal, so I know I've got the answer right. So as long as you've got time in an examination, it's always a really good habit to get into to do that last check, and if you realise that it doesn't work, you must have made a mistake somewhere in your working and you need to go back and find what that mistake is. Most common place for making a mistake is making an error with adding or subtracting, so getting negatives the wrong way round, particularly if you're subtracting a negative number. So try and go to the particular places where you're most likely to have made a mistake.